For the linear function given, we have to find the missing value and then give its equation as well. So let's go take a look at part A. We see that the increase in the x's is 1 unit, and what change does that cause in the f of x or the y's? Looks like if I add 2, I get from -2 to 0. If I add another 2, I get from 0 to 2. So if I follow the same consistent pattern, 2 plus 2 is going to be 4. The missing value is 4. And so that's part A. Part B says give the linear equation. F of x equals ax plus b, or now after finding out about slope, we call it mx plus b. Remember, this is the slope or the rate of change. And b is the sort of what we call the initial amount or y-intercept, which is associated with x equals 0. So from our table, we can say f of x is equal to the rate of change is 2, let's go back to where we were, 2x, plus the value associated with x equals 0, the y-intercept is -2. So our function is f of x equals 2x minus 2. Part B, again, it looks like the unit increase for the t values is 1, and what's happening to the y values, it looks like we're adding 5. So if I add a 5, here I'm going to get 20, that's part A. Part B, again, we're going to do f of t, use their variables, equals mt plus b. So f of t equals m, in this case is 5, that's the rate of change because the change in y over the change in x's is 5 over 1, 5t plus, and then notice the t coordinate of 0 corresponds to b, or the y-intercept of 10. So that's our equation, and let me make this a little bit clear. It's actually f of t. Part C, it looks like I'm going up 1 in the on the x values or the r values here, but I have to be careful because I'm going up 2 r values here, from -1 to 1, and here I'm going back up by 1. So I'm going to use that unit increase in 1 to guide me through what's happening. So 1 unit increase in r's gives me, it looks like, a decrease of 7 in the p of r's or the y values. Same thing better apply here. -3 minus 7 is a -10, so that works out okay. I just need to know what's happening right here in the middle. Remember, I'm going to need the r coordinate of 0 for my b value anyway, so I'm going to go and figure out what's going on there. I'm going to make my own little 0 here because a 0 was missing and it jumped by 2. So if I jump this by 1, then I'm going to actually decrease by 7, and 11 minus 7 looks like, I'm guessing, should be a 4. And then if I do that same jump in 1 from 0 to 1, is this going to be consistent with 4 minus 7 is -3? Yep, that works. So we're in good shape. We know what the change in y is going to be, or in the p of r's. So my equation is going to be, I guess there was no missing value for us to fill in. Maybe it was the missing value in the middle that I put in. So we're going to say, okay, that's done. Even though it didn't really put a little question mark there. It's okay. Let's go to part B, which says P of R is really MR plus B, using the variables here. So P of R, the slope is actually -7 because it's -7 over 1, dropping 7 for each unit increase in the R. So 7R plus B, I found that right here because I filled in my own 0, and that was a b or a y-intercept value of 4. Example 2 says use the graph to find the equation in slope-intercept form. So slope-intercept form is f of x equals mx plus b, which again, this is the slope or the rate of change, and this is the y-intercept, which is associated with the x value of 0. So I'm going to use their variables. They're just calling it y, so I'll call it y equals mx plus b. Y equals, let's figure out the b because that's usually quick to spot. Right there is the b value. So assuming we're going up by 1s, I'm going to say the b value or the y-intercept is 2. Now for the slope, I'm just going to count my steps to, let's say, over here, because it's clearly going through that ordered pair 4, 0. So counting my steps, it looks like I'm going down 2, and 1, 2, 3, 4 to the right. And then I'm going to go ahead and reduce that because I don't want to leave it in unreduced form. That's a negative 1/2 x plus 2. So what I did was I reduced the slope of negative 2/4, divide top and bottom by 2. That's going to be a negative 1/2 for my slope. And remember, I can put the negative in the middle if I want to, in the top or the bottom. Graph the line with the slope negative 2/3 going through the ordered pair negative 3, 1. So I'm going to start with this guy, negative 3, 1. 1, 2, 3 to the left and up 1. That's my starting point. And then the slope of negative 2/3, I'm going to look at it two different ways. I'm going to look at it as, let's do negative on top. So from that location, I'm going to go down 2 steps, 1, 2, and 3 to the right, 1, 2, 3. So what I did was I went down and right. I'm also going to, and that's enough, 2 ordered pairs, my MATLAB will draw the line for you, but I'm also going to look at it as 2 over, let's say, negative 3, so that I go up and to the left instead. So from my red location, ordered pair negative 3, 1, I'm going to go up 2, 1, 2, and left 3, 1, 2, 3. And that should be more than enough to draw our line through that. Okay, the graph shows the cost of removing X tons of snow. Find the slope of this graph and interpret the results. And there's a part B as well, so let's go look at part A. It says find the slope. So in order for me to find the slope, I'm going to find 2 locations that I can read easily. I can read this ordered pair, and that's going to be 4, 100. I can also read this ordered pair fairly easily. That's going to be 8, 200. So I can either use m equals y2 minus y1 over x2 minus x1, or instead I'm going to just read the graph. That might be easier for me here to do. Reading the graph, I'm going to notice that I'm going up not 2 steps, but actually it looks like 100 steps, because I go up 50 and then another 50 up. That's 100 units that I'm going to go up. And then I'm going to go over not 1 step, but look at your labeling of the x-axis, 4 steps. So my rise was basically 100, and my run is basically 4. So I had 100 over 4, which is really 25 over 1, if I go ahead and simplify it. And it says interpret the result as well. Well, the x-axis is snow removed in tons, so that's really 1 ton in the denominator that I could label it as. And my vertical axis was the cost in dollars. So if I am to interpret this, it's basically saying that each ton costs $25 to remove. So the removal is basically $25 per ton if I do the rate of change interpretation. Now give the equation of the line is what I'm also asking you to do. So for part B, I'm going to think of it as f of x equals mx plus b. And since our equation is going to be in terms of x and y, I'm going to say y equals mx plus b. And b from the graph, I'm just going to assume it's 0, so it doesn't cost anything if there's nothing to remove, plus x, and the slope we just found to be 25, so it looks like our equation is 25x. The y-intercept 0 saying no cost for removing no tons of snow, and the 25 saying that $25 per ton to remove.